Welcome everybody to our monthly online research seminar. It's good to have you back with us. We're still on a high from last month's hybrid face-to-face and online seminar. This month, of course, we're back to the bog standard online version. So welcome to you all. For those of you who are new to our series, my name is Dave Lamb. I'm the Chief Scientist of the Food Agility Cooperative Research Centre, and I'll be your MC. Firstly, let me just take the opportunity to acknowledge the traditional owners of the many lands and waters on which we all live and work. I'd also particularly like to acknowledge the Gadigal people of the Eora Nation as the First Nation owners of the lands from where our speaker is presenting from. I'd like to pay respect to the elders of all of these many lands and waters, both past, present, and emerging. So, for those of you that are unfamiliar with Food Agility CRC, we're a CRC dedicated to unlocking the power of digital to transform our agri-food sector. Now, before I introduce our speaker, let's cover off on some housekeeping. The session is being recorded and ultimately we'll make the recording available to you via our YouTube channel. I'm hoping that many of you are familiar with where to find those as well. Not only can you find this seminar after the event, but we've got quite a host of recorded seminars from the last 16 months. And of course, we have our annual summit from earlier the year. We welcome questions from you all, but please remember to use the Q&A tab at the bottom of your screen. Don't use a chat tab. I do keep an eye on it, but please don't do it because I've only got 2 eyes in my head and 3 screens. So use a Q&A tab. And whilst it's not possible for you to ask your questions direct to the presenter, yourself, at the end of the presentation, I'll work through them live and I'll retail them onto the presenter in a Q&A style. Of course, if you have a desire to follow up with our presenter after the event, then please do so. And you'll be able to find our presenter's detail via a very simple Google search, given the caliber and standing of our presenter. When you look at our research, development and innovation ecosystem that we all love and work in, and as we all increasingly generate and seek and access data from within, between and outside of our organisational constructs, organisational, disciplinary and domain-specific influences come into play in the data transaction process and how we behave and work with our collaborators. And this is really the topic of today's seminar. It's with great pleasure that I introduce to you our speaker, Dr. Paul Box of the CSIRO. Paul's a research consultant in CSIRO responsible for developing and leading a program of research into the social, institutional and economic aspects of large-scale distributed multi-stakeholder information platforms. This is the very ecosystem to which we are all working. In short, we're talking about social architecture. Paul's a geographer by trade who's worked globally in the geospatial information field in Europe, Asia and Africa for the United Nations, for government and for not-for-profits, designing, implementing and managing geospatial information systems to support sustainable development and humanitarian response in post-conflict settings. And it's a privilege to have Paul with us today to present on this topic. So welcome, Paul, and over to you.
Excellent. Thank you, David. And you would have thought by now I'd know where the mute button or unmute button is. Thanks for that introduction. And hi, everyone. Delighted to be able to present to you today. Let me just share a screen to begin. And just a correction for the record. I'm a Mr., not a doctor, just to start off on the with a correction of the record. 1 second. Let me share my screen. Okay, I assume folk are able to see that. Can't see anyone nodding, but shout out if you're unable to see the presented view. All right, assuming we're all good. Great, thanks, Dave. Okay, so yeah, the title of the presentation today is Wrangling Data Ecosystems, and I'll talk a little bit about just a bit of a framing for what we mean by data ecosystems. I'll talk then about this idea that we've been working on and an approach to addressing some complexity in data ecosystems called social architecture. And then I'll just cover off on a couple of examples around how we've used social architecture to help guide digital transformation, both at an enterprise scale within CSIRO, and then talking more broadly about an effort that we were involved with together with a range of other partners to develop the Agricultural Research Federation. Okay, so starting off with data ecosystems. So this is a kind of a traditional view of what we mean. You know, we talk about data, we think about silos often, and we've been successful in breaking down barriers to a degree and being able to aggregate data up, but we still have lots of silos of data. It's kind of a useful metaphor, but for me, when I think about data ecosystems, this is more the view that I have in mind, and this is a graphic from CSIRO's transport logistics tool, which tracks live or in near real time commodity movements around the country. And for me, this is really the view of what a data ecosystem is. The silos are where you can see stuff aggregated or where it's stored, but the challenges in shipping it around, the supply chain logistics, the contracts for haulage, the traffic management systems, that's the broader kind of data ecosystem in which we're operating. So moving back from the physical world back to the digital world, another framing for data ecosystems is information infrastructure. And there's a very rich body of literature, practice, going back, 20 odd years, 25 years in information infrastructure, and that's built on top of a really significant body of knowledge around socio-technical systems. And in this kind of framing, we're talking about the same thing, data ecosystems or systems of connected systems. But there's a recognition that these are socio-technical assemblages, and they're the information and technology components we see. Technology is very, it's pretty tangible. The information is the stuff that we create and flow through these initiatives. But the social components of this are often quite hidden, and they comprise things like the institutional arrangements, the committees we have, the rules, the processes, relation trusts, standards, culture, practices, and norms. And it's quite a complex set of interactions and social constructs, and often it's really hidden. So to social architecture, it's not a term I coined. It's something we picked up. It's a term that's often used to talk about, or was traditionally used to talk about kind of online platforms when they first emerged as being social architecture, allowing people to connect in the digital world. But we've really repurposed the term to talk about the conscious design of an environment that encourages a set of behaviors leading towards a goal. And in the context of data infrastructure and information infrastructure or data ecosystems, social architecture is the design of the social elements, the human elements of technical infrastructure. It's deliberately called social architecture to give it a bit of credibility in very technocentric kind of worlds in which we operate. So it sits neatly alongside information architectures and technical architectures. And it fleshes out these notions of governance and some of the hidden kind of networks which sit underneath our ability to deliver these infrastructures. And I'll touch on that a little bit more. So why is it important? You hear less and less, let's just build it and they'll come. There's a recognition that, you can build a perfectly good bit of infrastructure like a road. You get some of the settings wrong and the road doesn't work the way it's intended. And this is it's called a nail house. It's a phenomenon that emerged in China a decade and a half ago, where the government privatized land ownership and then got property developers to negotiate directly with individual property holders. No compulsory purchase, and maximum value of compulsory purchase was set. So, you've got the road designed perfectly, but you haven't quite got the institutional settings right, and therefore your road doesn't work quite as planned. And it leads to all kinds of things. People building shadow infrastructure, workarounds, and unless that infrastructure is working with the grain of the way that people work and bring people along with you, then you might end up with a perfectly good shiny bin with no data in it. So again, social architecture is really about developing socio-technical solutions. And this graph on the graphic on the left is saying that, data is really at the heart of this, data, information, and knowledge. It doesn't exist outside of technology. So technology enables us to do things with it, to collect it, manage it, ship it around, visualize it, analyze it. But all of that happens within a social, institutional, economic context. And that's where all of the decisions that are made in relation to the information model you choose to model your data, the algorithms you choose to reflect the world, the technology choices, who sits on the governance committee, they're all social. They're all human decisions, and they're wrapped inside a social and institutional and economic context. So social architecture really looks at all of those issues in a coherent way. It focuses in on the system we're thinking about, but because we're thinking of systems, it also kind of looks outwards from the system into the broader ecosystem. And we look at the three main areas: social, institutional, and economic dimensions. So things like social license, culture, attitudes, behaviors, privacy and ethics of the individual actors involved. Institutions, the legislation, policy, the rules of the game, the governance, standards, and importantly, incentives, which has an overlap with economics as well. And then in the economics space, it's kind of understanding data value, understanding emerging platform economics, which is a really interesting area of economics. And then the business models that go along with operating data infrastructure and trying to generate revenue streams, often for public good infrastructure and outcomes, which, as many folks on the call will understand as being quite a significant challenge. So again, social architecture is an approach to keep in mind these different perspectives, and we have a series of kind of diagnostic tools and activities which help us think about these different dimensions to be able to design solutions. This graphic is kind of a practical example of something we pulled together back in 2017, working on a project to try to develop a farmer's data market. And it's a graphic that serves us quite well. It helps to map on the different social, institutional, economic dimensions of what we're trying to do in building data infrastructure or building a system which enables the production and sharing of data. So it's quite a good generic model. In the center here, we have a marketplace, and that doesn't imply we're selling. It's just a place where people come to exchange value, exchange goods. We have providers on the left-hand side here who we're trying to encourage to put their data into the market, to share, to engage, and likewise data consumers. We have value-added service providers here who do things to the data to add value, and they may have commercial or other kinds of arrangements with data providers and the data users. Interestingly, in the center of the market here, we have three distinct kinds of goods: public goods, private goods, and club goods. So private goods, commercial data, you can't have it, or it can be shared. I control access to the data. You can buy the data from me, you can license it from me. Public good, open goods, and then club goods are this interesting form of data good or digital good. They're a good in the real world as well, but in the digital context, it's a pool of data. So if you contribute your data to the pot, you can get to see others' data. And this is where the likes of the big media platforms like Facebook make their money. You can look in from the outside and see certain bits of the graph of information. But if you live your life online in Facebook, then you can get to see everybody else's graph and interact with them. So club good is a very powerful form of incentive and an economic kind of reality in the digital space. So underpinning the market is and getting the different stakeholders interacting, including here the market operator, is incentives, which shape behaviors and attitudes. Incentives, in turn, are underpinned, shaped, influenced by the rules of the game. So this is kind of a classic market design construct where you have the market, the stuff is being exchanged with institution and regulation wrapped around it. But the important thing to note is the relationship between these rules of the game, things like standards, governance, IP arrangements, pricing, etc., that shape the incentives of the different actors to participate. So again, we've used this to describe, you can think of an NCRIS data facility as a marketplace. We think of the CSIRO Data Access Portal, our institutional repository, as a market. You can think about the entire digital economy as being a marketplace. So it's quite a good conceptual model to try to understand what the pieces are. So turning internally within CSIRO, I'll talk just a little bit about a couple of things we did applying social architecture to help us on a digital transformation journey. So within Land and Water and across the whole organization, but my business unit within Land and Water, we were looking at trying to maximize the value of our data assets and doing that through improved data practices, broadly defined. So obviously there's a set of tools, improved data management processes and tools which underpin our ability to do that. We also recognized that we needed new kinds of authority structures, roles and rules because we operate in projects and then there's line management, but we were lacking in some of those institutional arrangements. But we also recognized that we wanted to drive the institution, the technical by an understanding of the economics and social elements, so the value of data and our existing attitudes to data and practices around data. So I'll just talk briefly about two bits of work we did to understand the economics and to look at the social. So what we thought we'd try to do is to put data has value. How much is our data worth in CSIRO? So again, our Data Access Portal is our institutional repository. It's a trusted repository. It's been certified as such, and it's the place where CSIRO researchers deposit their data for internal use and for external access. So we started off by developing, working with some economists across the organization. We developed a conceptual model of where value is derived from, direct use, actually using the data to do something, indirect use, on processing it, turning into something else, option value, which economists are very fond of, are all use values. And then there are these other more abstract, harder to define values and non-use values, bequest and existence values. So we focused in on direct use value. We looked at our data holdings. We discounted space data, the astronomy data, because when it comes to big data, those guys win every time. It wasn't representative of the majority of other data we had. We focused on other kinds of data, and what we decided to do was to run a survey of people who download data. We then asked a very simple question: how much time did this download of this data save you? The lowest response we got in terms of the minimum amount of time was 38 hours. This data has saved me 38 hours worth of work. We multiplied that time saving by the number of downloads and the number of data sets to come up with the numbers that you see here. So an annualized value of $67 million. And this is it's kind of a ludicrously low band estimate of the value of the data, because it's applying the lowest answer we got to all the data sets that get downloaded. The point was we didn't want to come up with to conduct another study which talked about the value of data, and the number was a gazillion. This was really just to inform efforts and understand what kind of return on investment, how much we should be investing in the Data Access Portal. Okay, so we know that the data has value, but where's that value created? We thought about that value creation process a little bit. Data doesn't turn into value. It's the application of services to the data that generates value. There are certain services, like making it more fair, findable, accessible, interoperable, and reusable, which help in realizing value. But then there are other services which actually capture the value. Have a good idea about how the data can be used, turn it into a product, have a service offering, wrap a business model around it. And sometimes there are tensions between those realizing value and those capturing value. For us in this research, the research space, it kind of plays out around three areas, though alongside the value creation, there are costs associated with data. Production costs, costs associated with making the data more fair. There are data dissemination service costs, so your repository costs, and then data user costs. And depending on how much effort is put in by each of those stakeholders, the costs can shift around the system. So if there's very little effort put into preparing data by the holders of the data, the costs are pushed to data dissemination services to wrap meaning around the data and data users to figure it out and put it together. And that's a bit of an IKEA model, right? Flat pack data is just pushed out the door. The converse of that is putting more effort by research data generators in wrapping meaning around the data, making it analysis ready, maybe more cost borne by the data dissemination services, makes it easier to use for the users. So there are different costs, different models of where those costs live in that value generation supply chain. Also, interestingly, we kind of identified that the value curves for option value drops off the more data becomes processed, and the more direct value increases and indirect value increases as you move from raw data to service. So to unpack that a little bit, you imagine at this end you have raw meteorological observations, and on this end you have weather services. So as you process the data more and more, if you want to know what the weather is, you have a very high direct use value. If you want to do climate projections, then having weather services, although the direct value for that use is high, the option value for other uses drops right off. So it's another kind of construct or another view of the economics here that you have to figure out how processed the data should be, how much cost should be borne by who in the system. And I think APIs kind of sit around here. This is where you maximize your option value and your direct use value by building services on top of APIs that open up the possibility to use data in different ways. There's also a recognition, this came from some work we did a long time ago now, looking at archetypes of data supply chains for spatial data. There are different kinds of archetypes of supply chains from this anarchic view that the poor user has to go out and find all the data that they need and munge it together themselves. The user bears all the costs. Through to these other kinds of supply chains where you've got more aggregated, you've got an aggregator in the middle that bears the cost of integration, moving to kind of more federated and brokered, where you're pushing the costs to the providers of data to lessen the cost for the end users. So we need to be cognizant when we're working in the data infrastructure space of where are we now, where do we want to get to, what's the implication going to be in terms of moving cost. Okay, so we know that data has value, we know that there are costs in the system, but we want to look now at notions of value and the fact that we love our data, we think it's precious, and sometimes we may love it a little too much. So this is a slightly kind of a provocative slide. It's not week 3 of lockdown. It's actually a slide that kind of says, is there some real Gollum-like behavior around our data? And we wanted to explore this in CSIRO because we're often, as a researcher myself, I'm often feel like the finger is pointed as why aren't individual researchers doing more to share their data? So we did a bit of research looking at that. So we started off building a bit of a conceptual model of why aren't researchers sharing the data? Surely it's straightforward. You've got attitudes and practices around the data you generate in a project and you just publish it, right? But projects have contract and sometimes data is IP within them. It's not always clear cut. In projects, we're putting third-party data in, we're blending it. That comes with associated licensing agreements and constraints on what you can do. Within an operating environment, we've got business policy, practice, data ethics. In CSIRO, we operate within legislative mandate, which has an additional layer of complexity on top. Depending on the kind of discipline you're in, you've got your own identity group that kind of drives attitudes and behaviors. Depending on the sector you're working in, you have a different set of regulation standards, practices, and norms. And then all that takes place in a broader legislative, regulatory and policy context, which varies from jurisdiction to jurisdiction. On top of that, we've got arrangements and licensing and contractual arrangements around the third-party tools we use to store, access, and process data. So, it is actually quite hard for researchers to do the right thing with data. There's a lot of effort involved to navigate that complexity and push data out of the other end of the system. And our institutional arrangements, our capacity building, really have to reflect that. It's not as simple as just establishing a repository and some data management plans. There's a fair amount of complexity. So we tried to look at that in a bit more detail in CSIRO. We ran a survey across the organization to look at self-reported data sharing and to look at the degree to which organizational environment, the sector you work in, research discipline and researcher attitude shape self-reported data sharing behavior, and then correlated that against actual deposits in the data. We ran this survey, got about 800 responses, about 22% of folk in the organization. Uncovered a couple of interesting things. This first slide just talks about the channels we use for data sharing. 2/3 of the respondents talked about sharing of data, and we identified that in fact there's still an awful lot of data sharing that goes on through email and FTP sites, and we were quite surprised that that number was much higher than the CSIRO Data Access Portal. It's kind of identified two broad domains of data sharing through academic, broadly defined as academic data sharing, publishing data through journal repositories and academic social media, and then other more open data sharing through public web spaces, CSIRO's DAP under data repositories, etc. Couple of maybe interesting things. Academic data sharing is positively correlated with level of education. No surprise really there. And open data sharing was correlated with age and gender, with older male researchers more likely to use open data channels than younger and female researchers. So at the end of the research, we pulled together and did a comparison of the survey data about self-reported data sharing, the actual data deposits, and the conclusions were really culture and the openness of culture of an organization are really big determinants of data sharing. From the self-reported bit of the survey, we also identified the fact that big science characteristics are associated with more data sharing. So, if you're doing data that requires, if you're observing a large phenomena, or you're producing large amounts of data, space science is being a classic example, then data sharing is in the DNA of the discipline. Other disciplines are less motivated to do that, they're less driven to do that. So previous research, interestingly, kind of talked about the primacy of disciplinary influence on data sharing, but our study was a bit more nuanced, and it came back with the understanding that organizational culture really has a really important influence over sharing behavior. So we identified that in the organization there is, the kinds of practices, the culture that any given bit of the organization has is a really significant determinant of pro-sharing behavior. And in fact, CSIRO is a highly multicultural environment in terms of culture and attitudes towards sharing. And that culture kind of resides at a program level, which is, where our disciplinary line management silos of people are. Likewise, when we looked at the actual deposits of data in the DAP, we found that openness of data culture, as well as contractual inhibitors, were big determinants of data sharing. So, the ability to actually publish data if it's not commercial in confidence obviously has an impact as a constraint on data sharing. A couple of interesting observations, maybe this idea about data sharing messages, what's most likely to resonate with the community and engage people in I guess, investing in doing the additional work to get data out the door, navigating all the complexity that we've talked about, is really around maybe emphasizing the intrinsic benefits of data sharing, integrity and public benefit, rather than the extrinsic ones. This notion also of data as an asset is probably, could potentially be counterproductive, because sometimes, with the digital gold rush, there's now this notion that data has an asset and therefore we shouldn't publish it. And that's maybe not an individual researcher, that's maybe an organizational position, because we need to maintain the data, keep it close, and generate value out of that. So that's maybe a researcher and an organizational perspective. So what do we do with these insights in CSIRO? It drove the creation of a digital asset management committee, reporting to our leadership team within Land and Water. We had the fantastically named Dam Busters project, the digital asset management, to try and unlock our data assets, a whole bunch of technology activities along with the institutions. And the organization committed to this quite significantly with a day where we stopped work on other things and focused on data for the day. It was about half a day, learning about data practices, data tools, and a really big part of that was actually having a conversation with data culture, what it meant and what kind of data culture we wanted to have. And at a broader level, because Land and Water is a business unit within the wider CSIRO, the activity was interfacing with and influenced as well the broader CSIRO-wide digital transformation. At the whole of CSIRO level, there was a development of something called managed data ecosystems, taking a kind of an ecosystem view across the organization and managing data assets. We adopted FAIR principles, and a series of data clinics were established and continue to run to build people's capacity. All right, so that's the internal view and focusing on the social and the economic. I'll switch tack a little bit now and focus on the third pillar, which is institutional, and move outside the organization to talk about some work we did as part of a partnership funded by ANZ NCRIS, as it was at the time, ARDC, to establish the Agricultural Research Federation. Now, AgRefed was an attempt to bring together fragmented and heterogeneous agricultural data and make it accessible and reusable for research. The activity was led by FedUni in partnership with a bunch of other data providers, and CSIRO worked with FedUni and ARDC to develop a governance and data stewardship framework for AgRefed. So the focus of what we did was really to try and address one of these really significant challenges in building infrastructure, about the often disconnected relationship between governance and participation. So some work we did, again, going back a long time now, 7 or 8 years, analysing the National Environmental Information Infrastructure and governance arrangements for that infrastructure, where we built this very simple model that says you've got context, you've got governance of an initiative, which does the steering. The governance is basically an engine to produce agreements to drive collective activity, which happens through rowing. And there's a recognition in some of the work we did with the NEII, and subsequently it's a pattern we see all the time, but there's often a disconnect between that participation and rowing. If you want people to row in the same direction, you need to give them voice in the direction in which you're going. So you have to connect up those two bits of the system. And we often see there's a bit of a disconnect both within organizations and between the deciders and the doers. And then we also have that across organizations as well in these larger initiatives. That unless you've got people who are doing the rowing and actively informing and involved in decisions about where you're going, you get less participation. And there's a recognition also that a lot of work gets done through skunk work. There are these incredibly rich networks of collaboration beyond the formal hierarchies that define these initiatives, through which stuff actually gets done. So we need to kind of account for those in our thinking as well. So for AgRefed, we decided that the AgRefed should be designed in a federated, networked way, not a centralized data facility as lightweight and the center as possible to manage and make data accessible in the repositories in which it existed. We decided that we wanted to design it in a cooperative-like way, so not a cooperative organizational form, but some of the principles around cooperatives, with open voluntary membership, kind of a democratic member control, active participation, and autonomy and independence of the folk who are coming together in the cooperative. So using an architectural approach, this is the reference model for open distributed processing. You see these 5 different viewpoints, the technical views of the system, and then we focused on the enterprise viewpoint, which is all about the purpose, the governance, stakeholders of the system, and decided that the social architecture would really focus on 3 main things. What really around the concept of bringing autonomous communities together to collaborate. The 3 elements of this were the roles that individuals from provider organizations played in the collective, so that you're joining up the rowing and the steering. Identifying the policies that are produced through the governance mechanisms, focusing on key policies and getting the policy framework right. And then 2 alignment processes, one being fair and one being core trust seal, so that we could change current practice to get to a shared collective approach to doing things. So how does that look if we map it onto a kind of a pseudo architectural diagram? We've got data providers here, data repositories in organizational silos doing their own thing. Trusted repository is a international data council. I forget the organization that runs it, but it's effectively a mechanism by which you can validate the institutional sustainability of your data repository. So that was one of the first things we did, to say, well, if you want to manage data and deliver it into a collective, you have to ensure that the data is available in the long term. The shared bit of AgRefed looks like a typical kind of federated infrastructure. You've got a catalog and a data portal. Web services are making the data available. Metadata and vocabulary is published into the broader anchor space through Research Data Australia service catalogs, and then available and accessible outside of AgRefed through the main door of RDA, but also through the front door of AgRefed as well. This is where we put our effort by thinking about governance in this space, so the social architecture, and again, thinking about the roles, 2 kinds of roles, governance roles and substantive roles, the deciding roles and the doing roles, principally around stewardship, series of policies for how we make decisions and where we're going, and then the technical policies to guide the day-to-day work. And then these 2 alignment processes that I'll come back to. Trusted repositories, which is about this bit of the system over here. And then fair, which is about starting with data which isn't particularly fair or has a varying level of fair, agreeing what level of fairness, how findable, how accessible, or how interoperable should our data be as we contributed into this shared space. Just touching on a few aspects of that. One of the key constructs here was actually having a networked and federated arrangement where individual data provider communities that are autonomous come together and make decisions through the federation community. And there were 2 main bodies to do that, a council for strategic decisions and then a technical committee with representation of data provider communities on both of those. But this idea of a data provider community is one that helps us enable collaboration at different scales. So a data provider community could be, it could be an individual department within the university. It could be an entire sector. However, a data provider community determined to scope itself and assign representatives for that data community, they would then be in that federation community. So it's a really quite a nice scalable model for governance. And of course, it allows the data provider community to plug into other networks. Just breaking apart how that works a little bit more in terms of some of the key roles here. So in the provider communities, the host institutions that hold the data, you've got a whole range of roles around the data. You maybe have somebody who's creating, managing, curating, owning the collection. And you also have a generic role around who's providing the service that enables access to that. It could be the repository, web service on top of the data. So we abstracted that out, called it a provider role. So that's all about managing your own environment that enables access to your data from the point of truth. The Federation community roles, 4 main roles here. One is a council member, so a role sitting on the strategic guidance committee. Another representative role on a technical committee to make technical decisions. A Federation data steward to ensure compliance with standards to help people onboard their data into the system. And this important role, the provider collection custodian. And if we map those 2 together, then the provider community organizes itself and appoints one person to represent on each of those bodies. And they organize themselves also to identify who's the point of contact, who's the provider collection custodian to represent the interests of the data, to answer questions, and to provide a link between the provider community and the Federation community. So it was a good way of joining up, again, that steering and rowing, and allowing organizations to act autonomously, but still to have a collective view on what they're doing. Just a few notes on those 2 alignment processes. So we've talked a little bit about the Core Trust Seal, and this is really a way of, and I'd encourage folks if they're not across this to have a look at Core Trust Seal. It's a way of a checklist and a formal certification process for your data repositories, which help you understand and give confidence to those who are using your repositories that they are going to be there in the future, that they're sustained, they're institutionally supported. So there was a decision to use that as an alignment process, which was a governance decision. There was also a governance decision to use FAIR and the ARDC FAIR toolkit to set a minimum standard of fairness for data that was going to be shared through AgRefed. And then from that, the policy settings can be changed by the governance mechanism to dial up or down the level of fairness, because typically you need to start the process with fairly low bar to get the party started, as it were, and gradually ratchet up the level of compliance to improve the interoperability and the analysis readiness of your data. So this is an ARDC FAIR assessment tool that we use. And FAIR is not a binary, it's not yes or no, there are grades of FAIR. So the policy settings that we went through were to say, okay, what's the ideal compliance level and what's an aspirational kind of, what's the minimum standard in light green? And through that mechanism, through using a framework and then continual evaluation of where your community's at, you can start to improve the interoperability. 2 more slides. So just some takeaways from all of that. First up, that one of the key messages is we can't fix social problems with technical solutions. So we have to be aware of the social and the kind of institutional realities and design systems that work along those lines, and where necessary, think about changing the institutional and social elements. We can't neglect social architecture, particularly this connection between steering and rowing, and being a bit more sophisticated in our thinking about designing and allocating decision rights. Because quite often we just build a system, say we need governance, form a committee, usual suspects on the committee, and we never even check in with the committee to see whether it's operating effectively as an engine room for making decisions. So we need to be measuring and evaluating, instrumenting our social architectures, our decision-making processes as well. The key challenges that we face, and I'm guessing many folk on the call, is this challenge of avoiding infrastructure orphans. This is a phrase I use to describe the fact that we try to build infrastructure through projects, and projects start and end, and we're kind of often left with infrastructure which is unowned, unloved, rusts on, or dies on the vine. So what do we try to do to address that problem? We need to think about designing mechanisms and incentives that means that people still turn up when the funding runs out. So how do we wire in what we're doing and align it with the agendas that organizations have already? And that's a challenge. Just a few thoughts on making data fair. You need a really clear value proposition for fair. There's a lot of cost involved. There's a lot of capacity uplift required. We have to be really clear about the level of interoperability being sought, and therefore the level of fairness that's required. Really, heterogeneity, always a big issue. Many people are starting from a different starting point. We'll have a different level of maturity, different incentives, different culture, and that needs to be reflected in our efforts. Quite often there's the return on investment or the value proposition of making data more fair. It only eventuates after a while, after enough other people have made their data fair and that pot has grown and network effects begin to operate. So that's a bit of a challenge for us quite often. And we've talked about capacity building and core trust seal. Last slide. I just want to end on this one because it's kind of top of mind in everything that I'm doing at the moment. Really, it's around everything we've talked about is really on this side. It's around production, getting people collaborating more to produce information so that it can be delivered to users. But that's really rather a transactional view of science and of research. And in fact, we need to be moving into these newer modalities where it's not ask a question, crank the handle, give a response. It's actually around deeper modes of continued sustained dialogue and knowledge brokerage and innovation brokerage, where we're co-producing knowledge. We're actually doing this together, providers and consumers of the information, particularly in areas that are really complex, because the transactional modes we have at the moment are just not fit for purpose. So thank you very much for your attention, and I'll leave it there.
Thank you, Paul. The questions and comments are coming thick and fast, so I'll jump straight to them, noting how much time we've got left. So first of all, and there are a few of us in the audience, I guess, aren't familiar with some of the fundamentals. We'd like to hear it from you. Could you just tell us a little bit about what fair actually means in practice?
Okay, fair. So it's an attempt to a framework to help drive the interoperability agenda. So we've got lots of data. We don't know where it is. It's not described very well. It's got different structures. It's got different semantics. Can't be found. It can't be used. So FAIR is an acronym that came out of was it CoData? Somebody else, I'm sure, will throw a comment in the chat. Out of a global research community as an acronym to guide our efforts to improve interoperability and to get closer to analysis-ready data. So findable, better metadata, accessible, legal, technical access mechanisms, interoperable, standardized semantic structures of data, and the design goal of reusability. If data is produced by an economist, you need more metadata so that an ecologist can use it. So driving an agenda around that framework.
Thanks. Thank you, Paul. When you look at the breadth of data offerings in the marketplace, and with a focus on AgRefed, do you see the models and service offerings naturally assembling correctly around these social architecture drivers? Or is the process, or is what's being offered still quite clunky and needs a lot of back work and reverse engineering and purposeful inputs? How natural is the process in the marketplace for giving a nod to the social architecture demands?
So there are two parts to that question. One is the maturity of service offerings.
Yes.
So they are, I think it depends on the nature of the marketplace itself and whether it views itself as simply a repository for data, or whether it has whether it sees itself as a platform. And a platform is defined by being a place where people can actually generate value on the data. So, for example, in CSIRO, we have a Climate Resilient Enterprises, which is a data factory. It's an analytic platform and a way of starting to think about services and service offerings on top of that. So where you've got a data repository, typically the service available to users is discover and download. But more, depending on how you think about the marketplace, it could be actually an ecosystem, like a proper platform. I hesitate to use Amazon because it's kind of very successful, but maybe not the pattern we should be looking at.
Thanks, Paul. Do you know examples, or can you give us some examples of data federations that have worked well in disciplines outside of agriculture and RM? Any come to mind? For example, health law or anything like that?
I think there are lots of efforts to try to build these data trusts, data cooperatives, and to be honest, there aren't many examples of things that work particularly well. There aren't many that are kind of club goody particularly. There are many that are repositories which provide access to public data. I think it's quite a fast emerging field, and there's some good work being done out of New York City University GovLab, and they keep a running tab of kind of these data trusts, data federations, data cooperatives. To be honest, there aren't a lot of examples. I think as the data becomes more contentious, more valuable, harder to get hold of, it's really the examples of success become thinner on the ground.
Cool. Now, Paul, I've got one from Rob Banks here at UNE just down the road. Can you point to any good public examples of highly co-produced data systems that include payment or funding mechanisms where there are lots of non-linearities in the generation of value from data? And have you thought about Elinor Ostrom's principles for management of common or poor resources in the context you work on?
Yeah, absolutely. A big fan of Ostrom's work and the commons. So look, I think a lot of the cooperative work is kind of riffing in that common space a little bit, but of course a lot of Ostrom's work talked about the depletion of resources, and there are some interesting aspects of digital, which the fact that one person's consumption of resources doesn't prevent somebody else from consuming. So the economics are a little bit different. The first part of the question though was around examples of co-production of knowledge. Is that correct?
Yeah, public examples of highly co-produced data systems that include payment or funding mechanisms where there are lots of non-linearities in the generation of value of data.
Look, personally, we've been, we've gone through lots of innovation system activities and incubators in CSIRO. I've really struggled to find good models of. It's a challenge for a public good-oriented platform or capability to try to generate revenue streams. I think some work we did in the smart cities space was to think about kind of public utility models where government in partnership with the private sector, government may be funding licenses to manage a data repository, a data platform, and wrapping the right kind of rules around it to keep the data safe, enabling and reducing the cost for stakeholders to come together and generate value on the top of that marketplace, and ensuring that there's space for public value generation and private value generation. So that's the theory. In practice, again, very, very few examples of that occurring. I know there's a lot of, in the climate space, there's a lot of effort now in co-production of kind of narrative scenarios between experts and users of information to help guide decision-making. So there's some really interesting work happening in that space where, particularly where we're trying to understand what's coming down the track and what we're going to do about it.
Cool. Thank you. And it's a pity we've run out of time because there's a back of questions, but I might encourage anyone who'd like to follow up with Paul to contact Paul direct. Thank you for your presentation, Paul. It's generated an enormous amount of interest. Thank you all, ladies and gentlemen, for being a part of our seminar. So don't forget, we'll be releasing a recorded version of this seminar in the next couple of days. And as always, we'll send you an email link to our YouTube channel host where you can find them and other previously recorded seminars. Our next research seminar will be Tuesday, the 17th of August, so middle of next month at 2 p.m, the usual slot. And we'll be hearing from Dr. Mitchell Welch from the University of New England, who will be talking about computationally intensive research, computer vision, machine learning, and simulation, what I would actually call the art of analytics. So thanks again, Paul, and we look forward to seeing you all at our next seminar.